There's a lot of hype going on in blockchain space. Like people, they're crazy about like what Bitcoin is and what Ethereum is and like what's going on. Just prices are rising. Nobody knows anything. But looks like people want to learn, and the best thing right now we can do is educate ourselves on like what these technologies are, what they provide, and maybe like once you start learning, you kind of get deeper and deeper in like what the financial system is in general and like where it's all going, like how to set ourselves into the vision that given this technology, what the future might look like. So yeah, I was thinking to have this kind of intro course into what blockchain is, and I was happy to meet Matt at the Ethereum workshop that they gave. I really enjoyed it. It was a really good course on like just hands-on experience with Ethereum and smart contracts. And yeah, I offered Matt to speak to the rest of the team, but like he knows much more than I do. Like I've been just researching for it like a couple months or so, but you've been there for quite a while, right? So yeah, why don't you introduce yourself and yeah.
Sure. All right, we'll just kick things off. So my name is Matt Lockyer. Background as a developer, went on to do my PhD, did a lot of lecturing at the university level, where I kind of learned to communicate technology concepts to an interdisciplinary school. It's actually CIAT at SFU, so it's a School of Interactive Art and Technology. So basically that's a bit about me. As Igor alluded to, there's a lot going on with blockchain right now, and basically not a lot of kind of understanding, just a bunch of people like kind of flooding in and buying these cryptocurrencies. But we're going to talk more about like the technical and more about the applications of where the technology is going. I'm not really going to talk about price, so nobody here is going to get rich by the end of the day. But a little bit about like my company as well. We hosted this workshop on Saturday to like a crazy response. In the company's Vanbex group, it started out as a professional consultancy, just doing marketing services for people wanting to launch new blockchain projects and new like ICOs. Then it started getting more and more involved in the development aspect of the technology and actually developing products themselves. So that's kind of why we're hosting academy kind of workshops, and we're trying to kick off an initiative. We really want to grow the developer community in Vancouver around blockchain kind of projects and blockchain startups. So yeah, that's a little bit about us. So intro to blockchain. So today I'm just going to go over basically a technical overview. So like, what is this technology? How does it tick? And then I'm going to jump into kind of like why it matters. So why should you care about it? Like why is it different than just the internet or anything else? And then I'm going to talk about some business models and some value creation, some value capture. So just where are people kind of looking at the blockchain technology stack as to how they can kind of build products and solutions that actually kind of sustain businesses. So let's jump right in with the technology overview. So basically, the blockchain is this distributed, transactional, immutable database and protocol. So that's a lot to chew on, but basically it is a database that's shared by everybody. It's transactional, which means updates form transaction records. So it's like if you've ever looked at Apache Kafka, it's kind of like that. It's immutable, so basically once you've updated sort of data entry like in the database, basically you can't go back and say that it never equaled what it equaled before. It's always moving forward, so that's done through Merkle computing, but basically that's a computer science topic a little bit beyond today. And basically at the core, it's a database and a protocol. So how is it secured? Well, how are all people trading, Bitcoin and Ethereum and stuff, and how are they putting their faith in this database? Well, it's secured by mathematics, game theory, and cryptography. And so basically, there's a complicated sort of way to update the database, which I'm going to walk through step by step in the next slide. But this is kind of what secures people's faith and people's belief in the fact that this database has no central owner, no central authority. You're not going to the bank of Bitcoin to kind of update your account and credit your account and debit somebody else's account. It's all in the protocol. And the protocol is secured by math, game theory, cryptography. People are incentivized to keep this whole Bitcoin and Ethereum and basically keep the blockchain secure. So these transactions that people make, they're placed in blocks, and the reason why it's kind of based on blocks is because it helps make time and verification trustless. So you put a bunch of transactions in a block, you don't need to really concern yourself with whether somebody's computer is timed perfectly with your computer. You basically know that if these transactions fit into this block and that block was verified by the entire network, then we can now trust that block, and then blocks that come after it happen forward in time. So the block kind of concept is like kind of trying to get away from timing everything. So Bitcoin has 10-minute blocks and Ethereum has like 2.5-second blocks or something. There's a bit of different architecture choices there. So verification of these blocks, it's incentivized. So it's open to anyone. Anyone can download a Bitcoin client or an Ethereum client and go ahead and start trying to verify blocks. And you're incentivized to do so by a thing called a block reward. I'll get into it a little bit more in the next slide. But it's really important to know that it's also Byzantine fault tolerant. So there's this problem with distributed computing that came up, I think, in the 80s called the Byzantine generals problem. Basically, if a bunch of generals surround a city and they're deciding to invade the city, let's say there's 9 generals, and 4 of them rush in and 5 of them want to retreat, then those 4 are pretty much toast. So what you're trying to do is you're trying to get all the generals to agree so that the entire network is sort of believing in the next sort of updated state of the database. So that's kind of brought up a lot in blockchain sort of literature and in these white papers and stuff. So the important thing is that finalized blocks, the last step with the blockchain is finalized blocks are signed and connected permanently to the blockchain, and that's illustrated in this picture here. So what you do is you hash all of the data in the block that you're currently in, and you save that hash in the block that came before it, and you form a chain, right? So this is sort of through a cryptographic hash, and basically that keeps the database secure. So let's walk through the life cycle of a transaction. So again, I will be touching on some stuff, like I'm not going to go down the mining rabbit hole or anything like, or Merkle computing and tell you like how it's all kind of stored efficiently, but it basically is a transactional database. So we started with, block 0, no accounts, nothing. And then we basically started to issue transactions like create account, send Bitcoin, receive, right? Like, well, basically just send, and then the other person just gets it. You can't stop it from coming into your account. Basically, this is the transaction lifecycle. So some user will create a transaction, and then a node in the network will pool it into a block. So they'll take a bunch of transactions that are in their memory, and they'll basically say, okay, I think these transactions fill a block. Now I'm going to start to work on that block, and I'm going to broadcast that to the network so everyone else can start to work on it too. And then there's this thing where the network achieves consensus. So who is randomly selected as the main sort of winner of the block? And this is mining, this is related to Bitcoin and getting, earning new Bitcoins that are minted. I won't really go into kind of like how the algorithm works, but basically there's some consensus among the network as to who sort of is the main verifier of this block. They're going to win a reward, and then they're going to sign and they're going to chain it to the other blocks. And that means that the state of the database is now updated, and confirmations are just more blocks being put on top of the block that was just mine. So if you've ever heard somebody say, I'm going to wait for 2 confirmations, that means that 2 additional block rewards were given out, and these blocks were finalized across the network, and the whole network agreed this is the new state. So that's 2 confirmations. Typically for a high value purchase in Bitcoin, you'd wait for 6. And it's because, with every confirmation, the work that needs to be done to undo and to verify new blocks for the entire network gets exponentially greater. So that's why higher value transactions, you probably want to wait a little bit longer. But let's shift gears a bit, and let's talk about I'm going to transition a bit more into talking about smart contracts. So this is from Nick Szabo in 1994. So he's one of these cypherpunks, these guys that tried to create digital cash back in the day. And basically, Nick Szabo is trying to take a lot of subjective and sort of like wet kind of transactions that we have in our world, like property and like legal accounting, audits, and things like that. These are subjective. You need to bring humans into the room. You need to pore over invoices. You need to look over kind of legalese. It can be interpreted in different ways. So this is what he calls kind of like this is wet kind of transaction software. This is subjective kind of stuff. He wants to his vision is to kind of turn this into dry software-based code. So code is law. Basically, you enter into an agreement, it's right there in the code, maybe through some really awesome UX, it's communicated in a very straightforward way. Me and Igor could enter into an agreement to own something together on our phones just by kind of tapping a few times. And everything is executed by the software, by the code. So that's kind of like the vision for smart contracts. So let's take a look at the Ethereum blockchain, and these smart contracts actually exist today in a very basic form, but they are out there. So there's code being written in a language called Solidity. There's other languages. Solidity is more JavaScript based. There's other languages that look more like Python or Lua. But basically it's compiled into bytecode, and it's stored on the blockchain. So anyone can go verify that the hash of that bytecode and everything is all secure. And if you're entering into a smart contract agreement, you know that it hasn't been tampered with. Because again, the blockchain, it's immutable. At some point, somebody stored that code there, and that is in fact the contract you're entering into. Nobody can kind of swap it out on you. So it's stored on the Ethereum blockchain as a contract account. And this is a different account than like a wallet account. That's called an externally owned account, or an EOA. But smart contracts are stored as a contract account, and they're like a wallet account, but they're governed by the code that was originally stored. So these contracts, they have a key value database themselves. So they have a storage root that they start their state out at, whatever they were initialized to. And then basically, they get updated by transactions. So you make a transaction to a smart contract by calling functions. It's very wordy on these slides, guys, so I apologize. But we'll get into some fun stuff to take a breather from the technical. But basically, computational steps in Ethereum are charged in units of gas. So this is not a different monetary unit than Ether or ETH. It's the same settlement currency, ETH. You pay for gas, you pay for computational steps when you call a function of a smart contract. And the reason why you need to pay per computational step is because the Ethereum virtual machine, they toss around the phrase Turing complete, and it's not really Turing complete. It just basically has a gas limit. So if you were to let some smart contract out onto the Ethereum blockchain and it had an infinite loop in it, what would that do to the 40, 50,000 computers that are running the Ethereum virtual machine? It would brick the whole thing, right? Uh-oh, all these computers are halted on this piece of code, right? So that's where they came up with gas. They basically just said, okay, we're going to make people pay for every operation. We're going to make storage expensive. because again, the database is transactional and immutable. So if we make storage cheap, everybody's just going to start shoving cat images on the Ethereum blockchain and it's going to get super big, right? So they make storage cost something, and they have every computational step, even in a for loop. So every time you kind of churn through a for loop, you're costing gas. And basically there's an upper gas limit. I think right now it's 6.5 million. It's always kind of increasing, just, you know, as the rate of computers just get faster and faster. So that's a bit about how it works. These tokens that everybody are issuing, if you see an ERC20 token, or people say, you know, we are an Ethereum token, basically what that means is they are a smart contract on the Ethereum blockchain that represents a ledger, kind of like the main chain has accounts and balances. This is just another, this is a smart contract on Ethereum, so it's a contract account that maintains accounts and balances. So it's kind of like, you know, ledgers on ledgers. So that's enough for the technical. So I'm going to do something kind of a little bit more fun. We're going to just kind of take a break. We're going to think about, like, okay, we know a bit about this technology now. What about the features, the benefits, and the unintended consequences? So kind of like, why should I care, right? So just to kind of warm it up, we'll have fun. Just to kind of warm it up, we'll talk about some examples that are not blockchain, and then I have some blockchain examples. So a feature of the internet would be, you know, TCP/IP, HTTP, and the various protocols that kind of make up the web, UDP, all sorts of stuff, right? The benefit to that, to the world, is basically, you know, information exchange. It's now essentially free to talk to anyone in the world, video conference, share a photo, share a Google Doc. So that's kind of the benefit to everyone. Now the unintended consequence might be that what we've seen emerge is advertising and these walled gardens, like data silos, whatever you want to call them, are the dominant business model. So, you know, user data goes in and nothing comes out, right? Except for basically they're selling your attention to advertisers. So, smartphones, so wireless internet and photo. So basically, that's the feature. So we now got, you know, these really advanced things in our pocket. What's one of the benefits? We can share our experiences and moments and communication from anywhere in the world, right? So I can take a photo from the top of a mountain and I can send it to a family member. But some of the unintended consequences, message and location privacy issues, we've seen this with Google, you know, every 6 months, it's Google's tracking anonymous Android location data, even when it's turned off. I think that was the most recent one. I don't know. All the headlines are blurring together with the privacy stuff. So torrenting. So you can now download files piecemeal thanks to Bram Cohen and the BitTorrent protocol, right? So that's a feature. You can smash a file into a bunch of pieces and you can shoot it out onto a network protocol, and you can basically download these files piecemeal. That's a great feature. What's the benefit? Why should we care? It's faster downloads, and it's also reduced burden on the server. So you're now taking the load off the server and you're distributing it, right? And torrenting kind of feeds, some of the technology feeds into some of the blockchain projects. So this is kind of like the segue into the blockchain features. What's the unintended consequence? Well, piracy and perhaps death. But let's talk about blockchain. So basically, I'm going to go through 6 features of blockchain. So the first feature is it's public and it's permissionless. So that means it is open to anyone. Like I mentioned before in the technical overview, anyone can download a Bitcoin client, any piece of software. There's multiple different clients. As long as you can connect to the Bitcoin network and you can verify transactions, you're part of the network, right? So it's permissionless. You don't have to ask anybody to do this. It's an open protocol. You just connect. Same thing with Ethereum and a lot of the public blockchains. And I'm talking in this talk mostly about public blockchains because they're the coolest. So it's also, the benefit to that is access to global markets. If I'm in Lithuania and I can't open a bank account that gives me access to PayPal, right, that means I can't sell stuff. I can't sell stuff to global markets. I mean, maybe you can in Lithuania, I don't know. But there's some countries in the world where you can't get access to a good bank account that can connect you to PayPal or Amazon or whatever. You're walled off, right? Why? Because they don't want to take the risk or whatever. And one of the unintended consequences of these open networks, of course, you know, dark markets, Silk Road, other stuff like that, right? I'm not saying whether these are good or bad, by the way, the unintended consequences. So it's up to kind of interpretation, and I guess, you know, time will tell. But let's look at blockchain feature number 2. So it uses what's called pretty good encryption, or sorry, pretty good privacy encryption for all accounts. So this is a public-private key pair, right? And then every transaction is signed by the private key, and your public key is how you would receive funds and how people prove that you were the one issuing that transaction. So if you want to check out cryptography, it's another thing that's a bit beyond the scope of this, but check out PGP and just kind of go through a walkthrough of that if you want to know what it's all about. One of the benefits to somebody on the network would be there's no way to censor or hack transactions. So basically, you might have heard of Ethereum smart contracts getting hacked, and you might have heard of Bitcoin exchanges getting hacked, but it's really important to note and to separate sort of the type of attack. The Bitcoin blockchain, since it began in 2009, has never been hacked. The blockchain itself. Nobody has ever gone to a Bitcoin account and gone, you know, hey, I'll take your 100 Bitcoin and I'll move it over to this account, without the entire network achieving consensus on that was a valid transaction. So transactions since, you know, 8 years have never appeared out of thin air. And it's the same way with the Ethereum network. But the code, the script running on top of the blockchain, of course, somebody writes a little smart contract, it's got a function exposed that shouldn't have been exposed to a non-owner, some kid goes in and bricks the entire smart contract, totally possible. Right? And in the Bitcoin world, it was the centralized exchanges. So these are exchanges that were custodians of blockchain accounts, right? And they were keeping these blockchain accounts unlocked so people could log in and transfer money. So these were, you can also call them hot wallets. Basically, those centralized exchanges, custodians of you know, hundreds of thousands of Bitcoin accounts, they've been hacked in the past. So just keep that in mind, because it's a pretty fundamental feature and benefit of the blockchain. But of course, an unintended consequence could be funding illegitimate sources. So no nation state can come in and basically say, we don't like those guys, we got sanctions on them, we don't trade with them. Nobody can stop that, right? So blockchain feature number 3, there is no central authority. I alluded to that by saying there is no bank of Bitcoin. If you lose your private key or you lose control over the recovery to your private key, so a lot of wallets will encrypt your private key, give you a recovery phrase. If you lose your private key, you're toast. You can't, there's no bank you can go to and say, hey, here's my driver's license, here's my birth certificate, give me back my private key. There's nobody out there. One of the benefits of that, though, is that there's no arbitrary devaluation. Nobody can just print Bitcoins out of thin air, right? If you believe in the Bitcoin distribution, which is 21 million till, I think, 2140, and it's sort of getting halved at certain intervals, if you believe in that and you think that increased demand and a finite supply is a good thing, then, you know, that's what you believe in. That's how Bitcoin works. With Ethereum, there's no clear upper limit yet on how much Ethereum will be generated, but we'll probably see an announcement in like 1 or 2 years. One of the unintended consequences to there being no central authority is that you have to get everybody to agree. So you got to get miners, you got to get exchanges. You get, like, if you're going to do a fork of Bitcoin into the recent ones like Bitcoin Cash and Bitcoin Gold, you need to have a certain amount of mining power behind you to create a whole new set of, a whole new chain, right? And you also need to get exchanges on board to recognize this as a currency. So there's upgrade politics, and even with the Bitcoin core protocol, it has been updated, but there's a lot of politics involved there. So blockchain 4, this is feature number 4. So everyone validates the entire chain. So basically all nodes in the network, if they're full nodes, they eventually validate the entire chain. They can go all the way back to block 0 and quickly compute you know, what that account's balance is. And that's a great feature. The benefit is that it is fault tolerant. So nobody can kind of, like I said, you know, it's very hard for people to hack you know, 40,000 copies of a database at once and rewrite the past. So the unintended consequence of that, though, is that the blockchain is huge. So these blockchains, the actual ledger itself, like the Bitcoin blockchain, is getting bigger and bigger. The Ethereum blockchain is a little bit more of a complex kind of blockchain with the smart contracts. So it is getting bigger at a faster rate. And they have to come up with some solutions for that. So blockchain feature number 5, you have visibility into all transactions. So although, you know, maybe some bad actors might think that Bitcoin is super anonymous, if you provide the right sort of AI or whatever, you can quickly audit these accounts. So that's a benefit too. You can audit these accounts. These accounts can be externally audited without really having to kind of hand people a stack of invoices. So in double entry accounting, you know, we would have credits and debits maybe between a bunch of different companies. We'd have to have stacks of invoices and stuff and hand them to an external auditor. Here you just tell them, you know, what are the accounts of interest, and then they can just look at the blockchain and watch and check all the transactions. But an unintended consequence, of course, would be privacy issues. If somebody tweets about their Bitcoin account or they're using that account for crowdfunding, for example, and it's connected to kind of a more personal account, it's very easy to kind of draw lines between these. There are like anonymous currencies and stuff like Monero and Zcash, but again, I won't go into those. They're a little bit beyond the scope of this talk. So a feature number 6, this is the last one, guys. Thanks for bearing with me. Basically, peer-to-peer transactions. So right now, if I wanted to send anyone in this room Canadian dollars directly, there's no way to do it. If I want to jump onto Amazon.com and I want to buy something right now, there's no way for me to directly give money to Amazon. It's got to be through somebody, right? It's got to be through a bank, Interact Transfer, whatever you call it, right? Credit card. Now that changes things, because when I can send money directly and actually hold my money because I'm the only one that has the private key to that account, then we can start to create, and this is the benefit, I'm getting a little bit kind of out there, meta on this kind of talk, but it means that we can create networks of value around anything that we want to believe in. So it doesn't have to be the Canadian dollar. It could be something like Bitcoin or Ethereum, but it could be something totally different, right? So we can come up with new units of value as long as we can exchange them peer-to-peer and we can develop a tribe or a group or a community that believes in that. So another unintended consequence is the end of rent-seeking models. So basically rent-seeking is an intermediary that kind of injects themselves in an economic transaction or in an economy and basically takes rent, like takes a cut of transactions, but doesn't really add value. So if we can do peer-to-peer transactions, if I can pay Amazon directly and Visa doesn't get 3%, are we in a better place or a worse place than we were prior, right? So just something to think about. How am I doing on time? I have all the time in the world?
Yeah.
Okay, we're getting to the end, guys, don't worry. And then we'll do a Q&A. So I want to talk a little bit about the blockchain potential, kind of like the blue sky, right? Where is all this going? And these are the opportunities, the various business models that we're starting to see emerge, where value is created and captured. So if we rethink existing models, if we go back to Szabo, Nick Szabo's sort of wet versus dry. Let's get these subjective human-to-human interactions into some dry code, just make it really clear and simple the kind of agreements that we can enter into. Then we can rethink all sorts of models, right, and put them into smart contracts. We can rethink how we do peer-to-peer exchange and economies, little small microeconomies. We can put them into trustless, provable systems. So that's basically kind of a weird blockchain fancy way of saying, I can look at a contract and actually understand what it's going to do, and if it's legally binding, I can just tap it on my phone, and me and Igor, we're now in sync, we're in agreement. And maybe it's not just me and Igor buying something, it's a complicated sort of structure of a smart contract where I've hired Igor to do some work. There's 3 milestones there. He gets the payment at every milestone as long as I say that the work is good. If I say the work is not that good and Igor wants to dispute it, he says, hey, I did what you told me to do. We can take it to a tribunal. They can kind of arbitrate on that, but we have to pay a deposit to kind of get that settled. So we have to incentivize random users in the network to settle the dispute. But this can all happen with software, right? So we can speed it up and sort of make things a little bit more efficient and a little bit more clear as to how these transactions happen. So disintermediation of a lot of stuff, counterparty risk. So the reason why Visa takes 3% is because they spend most of their money chasing around risk, chasing around people doing bad things, right? And they basically, for the 3% that a merchant pays to Visa, the merchant can just go, I don't have to worry about it. I can take any Visas, right? Accounting, commerce, we can sort of, we can get rid of the intermediaries. I alluded to maybe we can potentially get rid of the need for external auditing if everything's kind of done on the blockchain in an open and transparent way. It doesn't have to be always 100% open to the public. It can be like open and trustless, but only visible to a few people. So there are sort of different models that people are coming up with for this. So it's not always just kind of out there. So I alluded to the dry software replacing sort of wet processes. So the monetization of open source software is really interesting. So if I said to you, hey, you can buy 100 packets of TCP/IP, would you do it? If I said that to you 20 years ago, you'd probably be like, yeah, this thing's gonna be huge, right? But unfortunately, just the way the protocols were designed and the way the software was designed at the time, there was no way to basically say, I own 100 units or 100 packets of TCP/IP. But that's kind of where we're going with some of these protocols that are getting created. There's the way to kind of own a piece of the protocol in a tokenized form, and then those tokens are kind of what gets used as sort of the gas or the oil or whatever you want to think of it, however you want to think of it, to power the protocol. So you can actually own some open source and some network protocols. Microtransactions, loans, insurance, and economies. Obviously, the transaction costs of doing things on the blockchain. For me to send some Ether to Igor right now, it costs about half a cent, so like 0.006 USD. And basically, it'll get to Igor's wallet in about 30 to 40 seconds. So, and it doesn't matter if Igor's sitting right here or if Igor is in Singapore, it's still just the same, right? It's a worldwide global network. Decentralized organizations, a lot of people talk about that. So they're leveraging the fact that these are free and open markets with near zero fees, right? And we can create a lot of organization around ideas. We can set bounties for work. So we can say, hey, I want somebody to do a logo. Here's $100 worth of Ether. If you do the logo and we say the logo's good, we're going to release it. It's right into your account. So faster, cleaner ways of sort of doing something like a Fiverr or like, I can't even remember the name of the other ones. Doing a Fiverr without the Fiverr, right? So without the actual company. Maybe let's create an Uber without the douchebaggery of Uber. Trying to get you guys. Let's create an Airbnb without the Airbnb, without the company, right? Let's create a peer-to-peer system, right? So global distribution of new currencies, communities, tribes, and ideas. So this is a global thing. Like blockchain is starting to see a lot of, you're starting to see a lot of third world areas kind of leapfrog because they don't have the traditional banking infrastructure that we have in the first world. When I was mentioning those examples of, sending money to somebody, of course I can send money to Igor. Like I can send him Canadian dollars. I just go to my bank account and I email transfer, right? It's simple. We've all done it. I can pay for stuff with my credit card. I got a nice limit. I don't take my credit card. I can buy a television. I can buy anything, right? Like a lot of stuff we can do in the first world. But in the third world, they can't do that. They don't have access to global markets. They don't have access to bank accounts. And like what we saw in Africa with mobile payments and M-Pesa, they are going to use this technology to jump over us. Because all they need is like a $300 computer. They write some code or they download a piece of software, open source software. They join the network. They start earning Ethereum. They start freelancing on the web. They start getting paid in Bitcoin. I mean, it just sort of kind of tumbles forward like that. So that's what's getting really interesting is that this is an enabling technology, and it's largely a global technology. So we're going to see, in my opinion, and this sort of goes into like severe kind of conjecture of where it's going, but we're going to see like a melting away of bureaucracy. So we're going to see governments getting more efficient. They're going to wake up and realize that they need to find new ways of generating tax revenue if people start disappearing into these global currencies. I myself have put some money of like some of my sort of disposable income into buying Ethereum and investing in like blockchain projects and where is that going? Am I going to actually take it out and bring it back into Canadian dollars? I don't know, but my money is just going into these markets. They're going into global currencies. So governments are going to have to get leaner, a little bit more efficient about where they provide services and how they generate tax revenue. Rent seekers, so definitely like these, guys that interject themselves in the middle of transactions and kind of arbitrage markets, you're going to see them just go poof, right? So just because they can time a stock purchase or something like that, and they say, yeah, we're awesome because we're, 1 foot closer to the New York Stock Exchange, that's all going to go away, in my opinion. And we're going to see the inefficiency of existing models get unearthed. So people are going to start pulling at the threads and go, hey, what's really going on with, the Federal Reserve or whatever. That's getting into tinfoil hat territory. But let's move forward. So let's talk about business models. How do you make money with blockchain software? Or how would you kind of approach? And this is just what I've seen so far. This is a bit of a coarse categorization of what I've seen kind of emerging so far. So there's the application layer. So that's really close to the consumer. So it's a SaaS model. It's an ad-based model, kind of like what we have today. Jaxx Wallet, CoinMarketCap, Coinigy, these are just examples of websites that give you analytics, insight into the blockchain. Jaxx basically is a wallet software. And for that, what are they doing? Maybe some data collection, maybe they're selling some advertising, maybe they're doing some analytics themselves on the blockchain, right? Decentralized applications are starting to kind of pop out. And basically, I think 2018, we're going to see a lot more decentralized applications. So these are things like the exchanges, the prediction markets, and the consumer platforms. So right now, a lot of the exchange is being done through centralized exchanges, but there's a very big push from the blockchain community to get these applications to become decentralized so that they're global, so that a nation state can't come in and basically say, well, you're domiciled in the US, we don't like what you're doing, we don't like this global currency called Bitcoin, so we want you out of here. So everyone's pushing to get things going in a decentralized way. So I think we're going to see a lot more of that. And how do they make their money? Well, they take a cut of the fees. Now these aren't like rent seekers. They actually add value. So if somebody's going to let me turn my Bitcoin into Ethereum, you know, if that's on a decentralized exchange and I'm paying 0.5% or whatever, then, you know, I'm just paying for that service, right? Protocols. So we're actually starting to see these protocol tokens. Their business model is through incentivizing other developers to build on their protocols and to build decentralized exchanges. But they themselves are a token and a protocol for decentralized exchange. So basically, the incentivization layer collects fees using their token, which puts like a market demand. It puts like a market, like an upward demand on the token. Because people need those tokens to pay the fees. Now, even if that's all abstracted behind the scenes, there's still like, you know, if I'm making an Ethereum to some random token decentralized kind of trade, then there's still, if the fees are collected in 0x, there's still behind the scenes going to be a little bit of a pull on the open markets, causing the value of the 0x token to rise. That gets a little bit more complicated, but basically, these tokens are going to be valuable because they enable all sorts of stuff, you know, storage, exchange, whatever. The actual blockchains themselves, so, you know, Bitcoin, Ethereum, I mean, if you believe in Bitcoin being, you know, this mathematical function, I wrote down intrinsic. Although Bitcoin doesn't have any intrinsic value, I mean, the code is there. It is real. It exists. Accounts are there. They have Bitcoin in them. Is it any different than, you know, gold in the ground or in some safe at, you know, Goldman Sachs? I don't know, right? It's whatever we want to believe in. So there is sort of like this value to Bitcoin and Ethereum that you kind of would buy it, you would hold on to it because it is in limited supply, it's digital scarcity, and you think that, hey, this stuff is going somewhere, you know, there's never going to be any more of it, so why don't I hold on to it? So value creation and capture. So in the internet, we had a lot of values captured at the application layer. So, you know, Facebook and Google, they don't pay for TCP/IP. They don't pay for HTTP. They just use it. They just leverage it, right? Very few people make money in the internet stack on the protocol layer. They make money by building applications, and that's where the sort of the business models of data and ads, you know, that's kind of where it came from. The blockchain stack looks a little bit differently. There's more sort of value creation and capture happening at these protocols. So, you know, tokens that you use to store a file or that you use to pay for computational resources. More value is being created at the protocol layer. But instead of just having one ginormous protocol to rule them all, you might want to maybe think about constructing applications with you know, a layer of thin protocols that kind of talk to each other. So there's a lot of kind of blockchain 2.0 talk, and that's basically a blockchain that's sole purpose is to bridge between other blockchains. So you can go from Bitcoin to Ethereum to Zcash. You know, you go to Ethereum to buy, and then you go from Ethereum to Filecoin to buy your storage. You go from Ethereum to Golem to get your compute resources, and that's how your application runs, right? So there's a lot of interconnected protocol talk happening. And I kind of alluded to this, public versus private chains. We're kind of in the 90s. It's the, you know, every company wants blockchain because it's the hot buzzword, but nobody really wants to be out there on the public, you know, blockchain because it's scary, you know, it's going to expose our, you know, our commerce and like our transactions. And yeah, those are valid concerns, but this is just sort of growing pains until we move forward, like into where we got to with the internet, right? 20 years later. So I'll just kind of burn through this. And the state of smart contracts today, so the Ethereum blockchain kind of has the widest adoption and sort of acceptance. Yes, the language is still in flux. Everything's still being built. I alluded to like Filecoin and being able to store a file in a decentralized way. That's not even done yet. That's not even built, right? There is a test network out and test technology that you can try out, like IPFS, which is the underlying technology of Filecoin, but it's not finished. It's not out there. There's no public Filecoin network yet. So this is evolving, like right now. It's happening today. Ethereum's a really good way to kind of get into the ecosystem. It doesn't really kind of, you know, claim to be the one and only blockchain, but it is, in my opinion, it's the most sophisticated to date, and it's got a lot of developer sort of support and a lot of easy on-ramps into it. So definitely check that out. And I don't really have a summary thank you slide, but I'm going to wrap it up, guys, by just saying that yes, it's early days with blockchain, but it's very exciting technology. And as I alluded towards with some of the peer-to-peer talk and the decentralization talk, I think we're moving towards a future where we are becoming more sovereign individuals. So when you buy Bitcoin, when you buy Ethereum, it's a PGP account. It's a public-private key. If you lose your private key, that's your responsibility. So part of the ability, or sorry, part of the responsibility of living in a peer-to-peer network and in a truly, you know, open network where I can send Bitcoin or Ethereum to anyone I want, part of that is responsibility. It's responsibility over, you know, your private key and your own stuff. As we start to build more and more into this technology, you know, more and more responsibility will be pushed to the individual, but that will only serve to empower the individual. So just kind of think about that, think about where it's going. That's where the technology is going. And of course, the price is going to the moon. I'm just kidding. Thanks, guys.